Hi there. Here is the reference angle worksheet. We did some of these problems in class, so you can get those solutions if you missed from the notes that I post, and I'll work through these other ones that we didn't do on the video. Okay, so we did 1 and 2. Let's try number 3. So the reference angle here is 23 degrees. We want to find what standard position angle would have that same reference angle. So, let's make a picture. Let's start in quadrant 2. Let's ignore quadrant 3 and 4 for now. So the reference angle, again, is the difference in whatever angle you have and the nearest x-axis. So in other words, how far away from the x-axis is it? So if we're somewhere in quadrant 2, we know that the closest x-axis angle, here's our x-axis, is going to be over here, and that would be in degrees 180 degrees. Okay, so the angle we want is 23 degrees away from that, and it's in quadrant 2, so it must be 23 degrees this way. Okay, so again, this angle right here, we call it our reference angle. That's 23 degrees, and we want to know what this angle is right here. What rotation would get us to this spot on our circle? So it's 23 less than 180. I know it's less because if I circle around in the positive direction, I'm going to hit this before I get to 180. Or an equivalent way to think about it, here's 180, here's my angle, it's in the negative direction from 180. It's clockwise. So I'm going to take, for quadrant 2, since I've got 3 different angles here, I'm going to take 180 and subtract 23. I want an angle that's 23 degrees less than 180. And that angle would be 157. Now for quadrant 3. So quadrant 3 is down here. My 23 degree angle is going to be measured from the x-axis to the angle that I want. This was 157. So what's an angle in quadrant 3 that has a reference angle of 23 degrees? So it's 23 degrees past 180. That means I'm going to add 23. So 203 degrees. That's this angle. I also want an angle in quadrant 4 that has a reference angle of 23. So it's going to be over here somewhere. Now, the reference angle on this side is going to be measured from this side of the axis. So the closest angle here, it's either going to be 0 or 360 degrees. And since we've rotated all the way around the circle to get to this point, we're going to be closer to 360 degrees than to 0. So we'll use 360 there as our basis, and then we're back from 360 by 23 degrees. So we'll subtract. Quadrant 4. So our angle is 23 degrees less than 360, which gives us 337. So that's this angle right here, 337 degrees. So each of these angles is 23 degrees away from the nearest x-axis. Okay, we did number 4 in class. Let's try number 5. So number 5 has a reference angle of 87 degrees, and we want to know what would that be in quadrant 2 and in quadrant 3. So quadrant 2 is going to be over here, and our angle is 87 degrees away from the nearest x-axis. Since we're in this quadrant, the nearest x-axis would be this side, 180 degrees. So it's 87 degrees away from that, which is almost 90 degrees away, but not quite. So here's our 87 degrees right here. That's our reference angle. So what's 87 degrees less than that? Funny you should ask. Let's find out. Subtract 180 minus 87 degrees equals 93 degrees. So here's 93 degrees. And check your answer and make sure that seems right. Hey, it's a little bit past 90. Okay, it's probably right. Now for quadrant 3. For quadrant 3, again, we're going to be 87 degrees away from the closest x-axis. The closest x-axis would be here at 180, and this angle should be bigger than 180, so we'll add. Quadrant 3, 180 plus 83 degrees equals plus 87 degrees. Thanks for catching that. Equals 267 degrees. So that's right there, just shy of 270, so that seems about right. Okay, we did number 6 in class, so I'm going to do number 7. Now this one is in decimal radians. Decimal radians. Okay, so I'm going to use numbers like 3.14, which is a decimal in radians, as my signposts. So I'm in quadrant 2 and 3. Both of these are on the left side. That means I'm going to be using the left-hand side of the x-axis as my basis for this. And so I'm going to use that angle I just wrote in, 3.14. So my reference angle is 1.2. How big is that? Well, pi is 3.14. Half of pi, which would be 1/2 of this calzone up here, is 1.57. Okay, so 1.2 is a little bit less than that. So it's going to be less than a full 90-degree angle. So there's my reference angle, 1.2 radians in the second quadrant, and into the third quadrant, 1.2 radians as well. So what are these two angles? Well, for one of them I'm going to subtract 1.2. So that would be, for quadrant 2, 3, again this is number 7. 3.14 minus 1.2 to get 1.94. That's here. And for quadrant 3, 3.14 plus 1.2, which is 4.34. That's this angle here. Make sure I got that on camera. Okay, cool. So there we have it. Again, your reference angle tells you how far away you are from the nearest x-axis. So you just either move in the negative direction or the positive direction by adding or subtracting. And if you want to see the other ones, they're in the notes, or I'll put them up right here. So you can pause it, take a minute to look at these. Number 6 is right here. Number 7 is over here. So there's 1, 2, 3, 4, 5, 6, 7 on alternating sides. Great. Now let's look at the rest of this page. Okay. So the angle is 330 degrees. We're given the angle this time. We just want to find the reference angle. So 330 degrees, count around by 30s, it's over here. So how far away is it from the nearest x-axis, which is right there? So what would this angle be? This would be 360 degrees. So how far away is 330 from 360? This is called subtraction. That's how you tell the difference between two numbers. That's what we want here, so we subtract. So we are 30 degrees away from the nearest x-axis. 3 pi over 4. Let's find the reference angle. 3 pi over 4 is up here. Here's our reference angle. We can mark it. This would be pi. That would be the nearest axis, which we can write as 4 pi over 4 for convenience. So how far away is 3 pi over 4 from 4 pi over 4? I don't know. Subtract. Turns out it is pi over 4 away. And that's my reference angle. And again, we call this theta, in case you missed that in class. Okay, 193 degrees. I know it's going to be a little bit past 180, so there's 193, there's 180. How far past 180, you ask? Well, let's subtract. 190 minus 180 equals 13. So this angle is 13 degrees away from the nearest x-axis angle, which would be 180. 9 pi over 7. Here's 7 pi over 7. It's a little bit past that. How far past? Well, this would be 3.5 pi over 7. This would be, if we add another 3.5, 10.5 pi over 7. So it's going to be actually a little bit closer to this end. So there's our reference angle. It's to the nearest x-axis, which in this case is pi, 7 pi over 7. So how far away is 9 pi over 7, our angle, from 7 pi over 7, the x-axis? It is 2 pi over 7 away. Negative 153. This time we're counting in the negative direction. Here's negative 180. We're going to be shy of that. Here's negative 90. Negative 153 is going to be in there, closer to negative 180. How close? That's the question. How far away is it from the nearest x-axis angle? So we subtract negative 153 minus negative 180. And again, I'm putting absolute values here because regardless of which order I subtract in, I could switch the order here. I want to come up with a positive answer. So make sure you pay attention to your negative signs here. You're subtracting a negative number. You're going to come up with a number that's smaller than either of these, 27 degrees. That's how far apart they are. Okay, so 13, 14, and 15 I had to squish together to fit them all on the same page. So I'm going to squish the graphs together too. Okay, let me make sure I'm in a good spot on the camera. Alright, so 13, we've got negative 7 pi over 6. So I'm counting in the negative direction this time. Here would be negative 6 pi over 6. Negative 7 pi over 6 is going to be 1/6 past that. And I pretty much just said what the reference angle was as I graphed it. It is 1/6 past that. You can subtract if you want to. Negative 6 pi over 6 minus negative 7 pi over 6 equals pi over 6, the distance between them. You might notice to come up with a positive answer each time, just take the angle, use the angle that is the furthest around the circle in the positive direction as your first number, and you'll always come up with a positive number. So there's 13. 14. We've got an angle of 5. Not 5 degrees, just 5. That means we're talking about radians. So we're counting in the positive direction. This would be 3.14 over here. This would be 1.57 more than that, so 4.71. This would be, if we make the full circle, 6.28. So where's 5? Well, it's somewhere in here, closer to 4.71. So my reference angle should be measured to 6.28. So how far is 5 from the nearest axis angle, x-axis angle, 6.28? That's a subtraction question. So 6.28 minus 5, how far apart are they? 1.28. And number 15, we'll do it in the bottom corner. So for number 15, our angle is negative 3.6. So we're counting in the negative direction this time. There's negative 1.57, negative 3.14, negative 4.71. So we're in here somewhere, closer to 3.14. There's negative 3.6. So how far away is it from the nearest x-axis angle, which would be negative 3.14? Good question. Let's subtract and find out. So negative 3.14 minus negative 3.6. Make sure your answer is positive here, and you should get, make that a plus, 0.46. If you have any questions about that, let me know in class, and have a good day.